Okay, the first part of my talk was kind of a little bit about the philosophy of what we're trying to do, because at least for me, I have to understand why it's important that I do something, or why would I do, I don't know what to do or how to go about it. I have to understand what the goal is. So I tried to lay out some ideas of and inspire you to think differently about resources and what our goals are. The second thing that I want to talk about is some of the science behind this, because again, it can't just be a nice story that we sat in this room on a beautiful Wednesday afternoon in Oslo talking about it and then nothing. It takes action after this, and we know we need to have science behind it to make it really come alive. So we started this experiment in 1981, so this year will be the 35th year that this experiment is going, and I tell everybody it started out as a 5-year experiment, so we can't count too well because here we are 35 years later still working on it. And as Arne said, when I started there, I started long before this project's been in place, so I've seen it from the very beginning and watched how we've changed the soil. Originally, this field that this plot is in was rented. We now own it, but we rented it from a neighbor because we wanted to take a piece of land that was being farmed with chemicals and transition it to parts of it to organic and map that transition. Look at what was happening to the soil, look at what was happening to the farm, and then try to develop a recipe or a program for farmers to follow to minimize or mitigate the negative impact that would happen on their pocketbook. So for example, you can see there's corn growing here. If you start by growing corn, you're going to fail. And we suspected that would happen, and we proved it did. I mean, you put corn in the rotation in the beginning of the year, so there was never a cover crop, no crop rotation, no microbiology in the soil, no compost, nothing there, and you plant corn, it get about this high and turns yellow. Basically, it's like a drug addict, and it's saying, where's the juice? There's nothing here to grow on. I can't grow. And so we can make recommendations to farmers like, don't start with this crop, start with that crop. Start with a legume, start with something in your system, start with hay. We had different production strategies that we could get people to start with. That was part of the experiment. But it then very quickly grew into a soils experiment where we started looking at what's happening to the soil. And now we're adding a third component to the study where we're starting to look at transitions in farmers. Because it's not just the farm that transitions, it's the farmer. And in fact, I was saying at dinner the other evening that we have a neighbor that we transitioned his dairy. In fact, it's that dairy barn in the picture. We transitioned him, that's how close he is to our farm, from conventional to organic. You can see he has a barn there. Well, he started to build this barn. He started to build a second barn. He only owns about 20 hectares, and he has close to 100 cows. And so he was purchasing in feed. And I said, I see you're building another barn. Why are you doing that? I need more cows. Why do you need more cows? Well, he said, I'm going bankrupt. I said, well, how many cows does it take to make money? He said, I don't know, but it's not 100. I said, well, my guess is it's not 200 either. What else can I do? I said, you're just going to lose twice as much money twice as fast. Yeah, but the bank will give me the money. I understand. I said, what if you transitioned your farm to organic? He said, do you think I would do better? I said, here's what we'll do. Because you're so close to us, and he's a nice young man, married a friend of mine's daughter, and I think they have 7 children now. They're Mennonite farmers. Anyway, every time he has another child, I say to him, how many children are you going to have? He said, I don't know. It still gets cold in the winter. So anyway, James said to me, what if I fail? I said, you're our neighbor. You're so close to us. We guarantee you won't fail. We'll work with you. I wanted to put pasture on our farm anyway, so we put 140 acres of pasture on our farm, and we graze his cows. We call it dairy daycare. So the cows come to our farm every day. And I said, we'll put money in the bank. If something goes wrong, that's your money. If you don't need it, you don't get it. He never asked for 1 penny of that money. But he said that in the beginning, I transitioned because I wanted to survive. But he realized that he had to transition his mind, not just the soil. in order to stay as an organic farmer. And if you would ask him today if he would go back to being a conventional farmer, he would say no. He said, I would never go back. I can't believe I farmed that way in the past. Now I see how things can change. His cows, for example, and this was the story I said the other night, he said, he came in my office about a year ago, and he said, I'm a little mad at you. What did I do? Well, he said, you transitioned me to organic. Well, that was a good thing. Well, you would think so, he said, but my wife was in the barn the other day, and she said, you know, the veterinarian never comes to see our cows anymore. He said, that's good. She said, yeah. And he said, that's because we feed them 100% organic feed, no chemicals in their system at all, 100% organic feed. I know, he said, that's good. And she said, yes, but we don't feed our children 100% organic. Aren't they more valuable to us than our cows? He said, okay, buy organic food. Then she said, have you priced organic fruit lately? She said, it's really expensive, so I want you to plant an orchard. So he said, now I have to plant an orchard because you transitioned me to organic. I don't want to grow fruit. I just saw him a couple of weeks ago, and I said, I didn't see any new fruit trees yet. He said, you should shut up. So we have a good relationship. But his farm is now profitable. It went from losing money to making money. The same farmer, the same barn, the same land, everything was the same except how he chose to use it. He chose to use his resources differently, and his family's health improves, his cow's health improves. You know, farmers can get very depressed when you lose money. For 3 years in a row, he lost money. He said, that's like you paying for the privilege of showing up at work every day. That hurts. So he wanted to sell his cows, and the bank said, well, you can sell the cows, but technically, they're not your cows. They're our cows. And if you sell them, that won't pay off the debt. How are you going to pay off the debt? What are you going to do? So you get to the point where you start looking for doors to get out of agriculture. And one of the doors you consider is suicide. And when people talk like that, it's scary. And so we have to transition farmers and move people because people are incredibly valuable. And James is a perfect example of that. Soil is the heart of this system. When we talk about this farming systems trial, it's really a soils experiment, and it's all about the soil. And there's so much more to it. In fact, there's people who are now beginning to put a price tag on organic matter. And if we can do that, it makes our job a lot easier to persuade politicians to change policy. So when we rather pay farmers, at least in the United States where we have crop insurance, if we're going to give farmers money, and I don't say we should or shouldn't, that's not up to me, but if we're going to give them money, let's give them money to do something good, like improve organic matter, because we all benefit from that. So the estimated value of the soil biota is $1.5 trillion globally. There's a value to that biology in the soil. And if we can put a number on it, we can begin to change people's mind. There's a huge diversity of what's going on in the soil. I don't understand it. Ernest, you met Dr. Chris Nichols, our soil microbiologist, when he was at our farm. And Dr. Nichols said, when I started getting my bachelor's degree, we thought we knew about this much about what was happening in the soil. By the time I got my PhD, we realized we probably knew about that much. She said, I told my father, you're the only person I know that paid a lot of money for me to get dumber. But we know so little about the interconnection of these organisms. We don't know how they get along or don't get along, and we don't really have to. We just have to know that they're there and that they need to be fed. So again, you saw this slide before. But there's so many things going on in the soil that we just don't understand. But just because we don't understand it doesn't mean we shouldn't pay attention to it. We very much have to do that. It's really a case where 2 plus 2 does not equal 4. 2 plus 2 can equal 8 or 10 because there's a magnification effect that takes place in the soil. We have worked with a researcher from the USDA, the U.S. Department of Agriculture, who came to look at our plots, and he said, if you look at the numbers, it doesn't work out. The organic systems are too efficient. They're much more efficient than the conventional system. So he wanted to look at what some of those efficiencies were. And he said, when you have mycorrhizal fungi, for example, you can get a lot more plant growth out of fewer pounds of nitrogen because the plant becomes much more efficient. The the systems that we developed for selling products and putting them on the soil are grossly inefficient compared to what the biology can do. So 2 plus 2 equals a lot more than just 4. And this is that study that came out from the USDA that talked about all the problems that farmers were facing with barriers to adoption and transitioning to organic. And so that's why we developed this farming systems trial. Again, one of the main reasons they said they couldn't transition was they didn't understand the nitrogen cycling and how they were going to get enough nitrogen into the system without having animals. Because if you have to buy manure or if you have to purchase nitrogen, organic nitrogen in a bag like Chilean nitrate or something, it's very, very expensive. You could not supply your whole plant needs with purchased inputs. It would just be too expensive. No one would pay for that. And then also in this study, it said what's lacking is some long-term systems trials to see what happens to these organic systems over time. Because you really have to measure these systems over a lifetime. Because all of us farm over a lifetime. We don't farm for 1 year or 2 years. We farm for 30, 40, or 50 years. And so you have to look at these systems over time. And because they're biological and because they are efficient, they change slowly. It's a little bit like if we all have children or grandchildren, and if you put them to bed at night and you wake them up in the morning, as a scientist, I know they grew, but I can't see it or measure it. But if you put them to bed at night and you woke them up 35 years later, you'd be like, whoa, what happened? That's what happens in the soil. We don't see all of these changes. They take place so slowly. So when you look at universities and you look at studies that they do, most of the studies they do are 2-year studies. Almost everybody wants a 2-year study. Very rarely will you get a 3 or 4-year study because nobody wants to invest money for 4 years. And so if we come along and say, we want to do a 35-year study, try to get money for that one. But 15 years into this study, the U.S. Department of Agriculture said, we don't believe that Rodale's numbers are accurate. So we're going to start our own long-term study. And they did. And they found out the exact same thing. And then Iowa State University started one, and the University of Wisconsin started one, and they found out the exact same thing. The conventional systems fail on almost every measuring stick you can possibly look at. The organic systems shine under almost every situation. Very rarely do they come up short. This was the field that we took. This was an aerial picture of the 12-acre site, about 5 hectares, something like that experiment's in. And again, these are our 3 systems. Organic, manure-based. So we bring manure onto the field. Currently, we bring it in as compost. And what we do is we measure the amount of nutrients or grain that we produce on those fields and how many cow units that would feed. And then that amount of manure has to come back to the farm, so it's a closed system. So if we need to bring a ton back to these plots, a ton comes back onto the plot. The organic legume-based system says, we're not going to purchase any nitrogen. All the nitrogen for that whole system has to come from the air. I say it's free. Dr. Nichols says in that carbon economy, we're trading carbon for some of that nutrients, which I understand, but financially for me, it's free. And in the conventional system, we use herbicides and we use fertilizer. In fact, we use our local university, Penn State University. They make all the recommendations for that field, just like they would for a farmer through their extension educators. Now, I don't expect anybody to read this page or the next page. Simply wanted to show you that if you look at this number down here, it says 46, and now it says 50. There's over 50 peer-reviewed research papers that have come out of this experiment. So we know that there's good science behind what we're doing. So the information that I'm going to present to you is based on a lot of very, very hard facts. The manure systems are different from some of the others in that they grow some different crops. Because we have cows, we have use for hay or corn silage. In a cash grain system, we don't have that because we don't have animals theoretically, so we have no place to sell that or use it. So this has a much more diverse rotation. It's, of course, organically managed, and the nitrogen source comes from manure, and there are some legumes in this system as well. So it's a very balanced system. When you add animals into a crop rotation, even if you're just using them as a grazing tool, We have many farmers who don't own animals. The animals, just like we have dairy daycare, they come to the farm, they eat grass, they poop, and they go away. Our soil health improves, and we don't need to own the animals to do that. So we have a new experiment that we're starting that's with 3 different state universities looking at the federal government is funding to try to get animals out of those feedlots back onto farms because that's where they belong. Can we do it economically? Yes, we can. And can we do it and improve the health of the soil while we do it? Yes, we can. So we win on every measuring stick. The legume system has fewer crops in its rotation because it only has crops that we can sell. We can't feed it to anything. And the nitrogen source has no manure, no compost. So we know that we could hybridize these systems and make something really good, but we've sort of separated them, all 3 of them, to keep them very distinct so we can see what's happening to the soil. And then finally, the conventional system has only corn and soybeans in it, so it's a very limited rotation. Follows kind of a Midwestern United States rotation of corn, soybeans. And then there's tillage and no tillage in there. I'm just going to skip over that just for the sake of time. And this just kind of shows you how complex the crop rotations can get. And what's really interesting is if we just look at this year 1, 2, 3, 4, 5 across the top, and this is the conventional system here. Corn, soybeans, corn, soybeans. And these are calendar months, April through January, January throughout the year. What's really interesting is look how much of the time we're actually using the soil. Now, this corn is planted here and it's very, very tiny. It's actually getting bigger right about here, and by here it's starting to die, and so it's brown, so it's no longer collecting energy from the sun. So you're using it for about 2.5 months out of the year, maybe 3 months. The rest of the year, dead. Now, you picture rain coming onto this. This is a very leaky system. All the nitrogen that you put on here just leaks right out the bottom. There's nothing there to catch it. There's no crop there. There's no living roots there. The biology is dead. It's a very leaky system. With the legume systems and the manure-based systems, we're starting to close those gaps. So we have a cover crop through the window, then we have corn, then we have rye, then we have very few windows for the system to be leaky. Some places there are. Wherever there's a leak in the system, it's our job as a farmer to try to figure out what I can put in there. Or it's my job to try to rearrange the crops so I can create more windows of opportunity to get cover crops in. Because as we launch into this conversation on no-till, you'll see that cover crops are the key to success. So on our farm, when people ask me what I grow, I say cover crops. I'm a livestock farmer that grows cover crops. Now, I can't sell the livestock I produce because it's under the ground, and I can't sell cover crops, so I plant other crops just for something to sell. But if my goal is to improve the health of the soil, then that's my job. My job is to improve the health of the soil, not to sell crops. I have to sell crops to stay in business or someone else will get my job. But if I concentrate and focus on the soil, the crops actually grow themselves. It's so ridiculously easy to grow crops if I do everything else right. And if I do everything wrong, it's so ridiculously hard to grow crops. So again, we have these diverse rotations that we're trying to manage. And over time, the rotations have changed. And again, what we're trying to do, we played around with some wheat in this conventional rotation. We took it back out because it wasn't profitable. It didn't make money. This system is driven completely by yield and profit. Short-term yield. I got to have it or this system fails because I have to pay for all those inputs. I talked with a farmer I see him every year at a meeting, and I talked to him in 2014, and he was growing corn. And I apologize for bushels, but it doesn't really matter. He said, I grew 268 bushels per acre on 2,500 acres. So that's a big farm. 268 bushels. He said, you can't tell me my soil's not healthy. I said, yes, I can. How many bushels of corn did it take to pay for the inputs? He said, 250. I said, so you grew 18 bushels of corn. No. He said, I grew 268 bushels. No. It cost you 250 to do it. You grew 18 bushels of corn. I can plant corn out in the sidewalk here and get 18 bushels of corn. I saw him in 2015, and he came walking towards me before he used to avoid me, and he said, you really pissed me off. He said, all year all I could think about was 18 bushels of corn. I said, how did you do this year? He said, not as well. He said, I still paid 250 bushels of corn worth of inputs, and I only grew 248 bushels. I lost money on every acre I produced. He said, I have to change. You were right. I was wrong. Boy, that's hard to swallow. I'm doing everything the way the university says to do it, and it's wrong. It's wrong. The health of my soil is just there to hold the nutrients that I put in, and there's nothing left for the next year because it's a very leaky system. So we need to start concentrating on these other rotations. Rotation is key. We certainly want to minimize soil disturbance. Again, picture yourself as an earthworm. Here comes a plow. Is that a good day or a bad day? That's a bad day. So we want to minimize that impact. So we have to think about these things as we're farming, because we're now farming for soil health. We have to keep the soil covered. When the soil looks like this, it's so much better than when it looks like this. And that's something we can control. There's a lot of things you can't control on a farm. But the way you till the soil and you manage it can. So again, if you look at the complexity of the rotations and the changes over time, you see how the conventional system, there's no biodiversity here. It's not very complex. We've made it really, really simple. In fact, I know many farmers that don't even plant soybeans, they just plant corn. I have a friend who has 3,000 acres, 1,200 hectares, continuous no-till corn for 42 years. I've known him my whole life. He went to high school with my sister. He owns a planter, a sprayer, and a harvesting machine. And he complains he can't make money. I said, you have a part-time job, and you want a full-time income. You work for 5 weeks in the spring and 5 weeks in the fall, and in between you do nothing, and neither does your soil, and then you complain it doesn't make money. So in fact, he said to me, he comes to our field days in the summer because he has nothing else to do, and so he comes to see what's happening on an organic farm, and he said, I believe that I killed my soil, but what can I do about it? He said, you think if I put some compost tea in my soil, I would see an improvement? I said, well, we can try. I don't know, because your seed is already treated with a fungicide, so I don't know if that's going to impact the fungus in the compost tea. But he changed his planter around, and we put 5 gallons per acre of compost extract into his fields. He would turn it on, turn it off, turn it on, turn it off across a few hundred acres. And when we came in with the combine, every place that he had turned it on, he got a 15 bushel bump in yield. The second year, he got an additional 11 bushel bump. He said, the soil rewarded me by I fed the soil and it rewarded me. I said, yes, you're taking care of the soil. So he's thinking differently about, now he has honeybees and he's trying to think about farming differently and getting away from that kind of a rotation. This is just a map to show you the complexity of the experiment, and most of the information about this experiment is online on our website. All those papers, those peer-reviewed papers, are online. You can get them and read them. And of course, our scientists are always happy to talk about this experiment if you'll come and see us. I'm going to jump past some of this. It's kind of complicated. Again, we don't just look at yields. We want to start to measure soil health, but first we have to determine what kind of measurements we're going to take. And we need a lot of input from people in this room. You can go to the doctor and get your blood pressure taken. It doesn't mean you're healthy just because you have low blood pressure. You could come in smoking and hacking and barely able to walk, and they take your blood pressure and go, yeah, you're healthy. No. I have a brother who's not healthy. The doctor said he's the most fit, unhealthy person he knows. Because he exercises all the time, he's just got some medical problems. So we have to figure out, how do we determine what health is? It can't just be soil organic matter. There's many other things that we need to measure, but what is it? How are we going to define soil health? I will tell you that in the United States, there is a group called the Soil Health Institute. You can look it up online. I'm on their board of directors. I don't know if I want to be, but I am. They're raising money right now to sustain the institute, and what they want to do is they want to control the message and the language around soil health. Monsanto put in $20 million. The Noble Foundation put in $20 million. The Buffett Foundation put in they want $200 million. With $200 million, you define what healthy soil means. It's scary. People want to control that language. Because if you can say that what we're currently doing with Roundup and everything else is making soil healthy, then you win the argument of the minds of the consumers in the population. Why should you change? Again, the first part of our conversation here was all about why we should change. If you don't believe we should change, then there's no reason to continue the conversation. And so there's a lot of money being spent to control what this means. And you should be aware of that. And you have a voice there. We look at water quality. We look at energy analysis because it takes energy. Anybody that thinks fuel is going to be cheap forever is foolish. And of course, we have to look at the economics because we have to stay in business. What's really interesting is when we look at the long-term yields, and these are all long-term yields here. They're all the same. We have some short-term yields here that are only looking at 3 years worth of data because that's all we had for the no-till at the time. And you can see there was a slight advantage there in those 3 years. But over time, what we see is those things average out. And the manure system actually out-yields the conventional system. Same thing was true with soybeans. Same thing is true with wheat. Almost exactly the same yields. So when people say you can't produce, in the beginning people said, oh, you can't farm organically. It's just for gardens. It's nice for hobby farmers. So we proved we could do it on a field scale. And they said, oh, you can do it. Okay, you can do it, but why should you do it? Because there's no advantage in the soil. Soil's all the soil. So we show there's a difference in the soil. And now people are saying, okay, but there's no just because there's a difference in the soil doesn't mean there's a difference in the food. So now we're starting to look at nutritional quality and values. Because anybody that believes that if there's no difference in the soil is again, silly. We can see that simply looking at a crop like milk. If our cows in spring, we have a grass that's called onion grass. It smells like onions. When cows eat it, the milk smells like onions. So people say, well, milk is all milk. Really? Who believes that? What the cow eats is in the milk. What we eat is in breast milk. It's in babies. It's in us. It can't help but be there. So when you look at the long-term yields, they're really all the same. I'm going to jump over some of this rather quickly. What's really interesting is, though, when we have droughts, the organic systems work better. The conventional system, I don't care what you're growing. I don't care if it's cucumbers or watermelons or wheat. The conventional system is like a thoroughbred racehorse. It's designed to run really fast when the conditions are perfect. But when the conditions fall apart, the system fails. It's finely tuned, and it depends on those interactions with the inputs and the crop. And when there's something blocks that interaction, too much rain, the nitrogen leaches out of the system. Not enough rain, the plant roots don't have mycorrhizal fungi, they can't forage for water. So when there's problems, the system falls apart. The organic systems are more like an old workhorse. It just gets up every day and goes to work and delivers at the end. Never the highest yield, but never the lowest yield. So when we argue with our U.S. government all the time about crop insurance, they actually charge organic farmers more for crop insurance because they say your system's more risky, when in fact it's less risky. It's the conventional system that's prone to risk because you have highs and lows in production. I don't like wordy slides too much, but I think this one is important because if you look at the yields, basically what we're saying is we took the first 30 years. Over 30 years, the yields were basically the same. There was no difference at all. 4 out of 5 years of a moderate drought, the organic systems were 31% higher. When you look at weather patterns, what are we seeing more of worldwide, not just in Norway or the United States? More wet periods and more dry periods. It's never normal. What's normal? It's not there anymore. It's changed. In 2013, we had a drought during the growing season. For us, our soils don't hold much moisture, so we had 7 weeks with no rain. But it was the wettest year on record. So we had very heavy rains in spring, very heavy rains in fall, and a lot of snow in the winter. So when they looked at it, they said, oh, twice as much rainfall as normal, but while we were trying to grow crops, we had a drought. But we could drought-proof our soils in the organic systems. So in the last 3 years, we've had 2 of the wettest years in record and 2 of the driest years in record. I mean, it's just goofy. So how do we mitigate that? And we already saw this picture. Now I'm going to jump over some of these slides. I don't expect anybody to read this. The only thing I tell people all the time is it's incredibly important that you take a lot of soil tests. We haven't been able to define exactly what we mean by healthy soil, but we want as many windows of opportunity into looking at the soil as we possibly can. So we soil sample every field on our farms every year. People say, oh, that's a big expense. That's way cheaper than fertilizer. Way cheaper. And what I'm really looking for is trends over time. Because when you take a soil sample, we all know how that works. You know, you have a 2-hectare field, and you go out and you take samples, you put them in a bucket, and then you grind it down, and you get smaller and smaller and smaller until eventually it's in an eyedropper. So from that one drop of liquid coming out of a test tube, they're going to tell you everything you need for that farm. Well, you better have a good sample. And if you only take that sample once every 5 years, you might as well not bother. Because how do you really know what's going on there? So we sample routinely the same time of the year, every field over and over, and I start to look for trends. And what I've found is I have to buy very little material. When my son got out of college, he was a soil scientist. He got a job for an organic fertilizer company, and he was intent on selling me fertilizer. And I said, I don't buy any fertilizer. I don't need it. And he said, oh, that's not possible, because you have good yields. It's not possible. So I gave him our soil tests. And when you look at our soil tests, it just, you know, you can see here our soil organic, this is from our farm, our soil organic matter content is 6.1, 5.9, 7.0%. We have good soil organic matter content. We have good biological life in the soil, and the biology of the soil is mineralizing all the nutrients that are already there, so I don't have to buy it. And they're keeping it in place, and they're very efficient in how they use it. But if you don't take these soil tests year after year after year, you don't really get to see these trends. So if I were soil sampling my soil, this is not a map of soil. This is a chart of the New York Stock Exchange. But it gets my point across. If I were sampling here, I would say, ooh, whatever I'm doing is bad, because my soil test looks like it's going down. If I sample it over there, I think I'm like God's gift to soil, because it's really going well. When in reality, I'm trying to watch this trend line. You don't want to overreact, because we do that all the time as people. We're pretty smart. And so we see something, we see a problem, we go, oh, I have to do something. I don't have to do anything. It's getting better. It'll take care of itself. But my natural reaction is to do something, and then when I do something, I screw it up, because we all do that. I had a friend, well, it was my wife's friend, actually. She got sick. I don't know what the problem was. I don't remember. And she got medication. And she took the medication, but it had some side effects. So they gave her medication to treat the side effects. After a year, she couldn't get out of bed. She got a new doctor. He said, you're taking 30 different medications. He said, I don't know what the problem is. He said, let's put you in the hospital where we can monitor you, take you off of everything, and start over. She walked out of the hospital taking no pills. We do the same thing with the soil. We overreact because we think we know what we're doing, and we don't. What we do know is the soil needs to be fed. It needs housing for those microbes. It needs to be covered with something green and growing 12 months. There's things we know. Let's do that and then monitor it and watch what's happening. So that's what we've been doing in our soils. And what we've also been seeing is that not only are we sequestering more carbon in the organic systems, but we're sequestering it at greater depths. So we've got earthworms that are dragging that carbon down into the soil. Dr. Ratan Lal at Ohio State University is one of the world's leading authorities on soil carbon and no-till. And he will say that conventional no-till farmers will sequester carbon in the top few centimeters. And they do any disturbance to that at all, it's like putting a match on tissue paper. Burns it right back into the atmosphere, gone instantly. In the organic systems, we're dragging that carbon down to greater depths. And we've got carbon that we're dragging down to 80 centimeters. I mean, it's going down to the soil where we can sequester it for hundreds or thousands of years. And if we look at aggregate stability, we're changing this, and you saw that in that picture where the soil stays together in the water. This is just, again, putting some science behind it and showing that there's really hard numbers. It's not just taking hands full of soil, which is something all of us can do as farmers, and putting them in the water. It's actually mapping that and monitoring it. We do a lot of water data. We talked about that, the atrazine in well water, and how that's contaminating and polluting wells. So what we did was we created these intact soil core lysimeters. This was another, I'm really fortunate. I've been at Rodale a long time, and nobody stays anywhere that long unless they're really enjoying what they're doing. And they let me play with things when I want to try new ideas. So we created these intact soil core lysimeters, and now they're all over the world. We created a hammer to insert them into the ground. It was a lot of fun. And we built these. These are 30-inch or 76-centimeter well casings, so they're big. Put them in the ground, and underneath there we have a carboy to collect the leachate. So we farm over the top of it, water that percolates through the system. On our soils, once you get to about 1 meter in depth, any water that goes below that just continues to go down. And at some point, you will drink it. And so we can monitor and capture what's going on in there, and you can see these pits that we have. So we have a lot of good water data. And what we're seeing is, again, in the United States, we still use atrazine, and we know it's carcinogenic, proven to be a cancer-causing material. We see that in the leachate, it's 3 times the EPA's maximum contamination level for drinking water, even after they changed the level of drinking water, because they changed it because it's in the well. So we know it's going down, and we know we're going to drink it. What we don't know is what happens when we drink it, because you don't just drink atrazine in the well. All of those chemicals that we put in there, it's like a chemical soup, all go down there, and we already talked about chemical reactions. They interact and react with each other, and we don't even know what they form. We've never looked at that. So when the EPA looks at contamination levels, they look at them as single products. We know they also look at them with male rats. Why male rats? Male rats are not nearly as susceptible to changes in their hormone levels and in cancer susceptibility as female rats. So all you women in the room, I guess you don't count. We need to start doing accurate tests on that chemical soup using a mixture of populations, not just rats, male rats from populations that we already know are not predisposed to getting cancer. It's crazy, but that's what they do. So we need to pay more attention to those things. But we know that that's in the water because we have a lot of good data. I think they said on our water data points right now, we have about 45,000 data points. So we collect a lot of water samples, a lot of data behind this. We know that there's 15 to 20% more water percolating into the organic systems. You saw that in that picture of the wheat, where the water actually soaked in, and we captured that water so we can use it again. So there's a lot of great information. And then there's some data that talks about what atrazine does at very low levels, 0.01 parts per billion. That's not much. And it changes frogs to become hermaphrodites. Why would that interest us? You know, frogs, we can ignore frogs pretty well. The problem is the human fetus, when it's in about the 8-cell stage, is exactly like a frog. And the switches are being turned on and off. Now, I'm not saying people are hermaphroditic, although we're seeing more of that. What we're saying is we have more attention deficit disorder, more autism. I just heard a woman talking about a study on National Public Radio. I think maybe it was the BBC, I don't remember. She was saying that when she started in the 1960s working on autism, the rates were 1 in 10,000. She said, by the time I retire, they will be 1 in 20. What's changed? She said the way we produce food is what's changed. The way we manage the soil is what's changed. How are we going to handle that? It's in the water. And you saw this picture before. Very dramatically shows you how the soil interacts and changes its response to water. And then we do a lot of economic analysis because we know that the economics is really incredibly important. And throughout the 1990s, the organic premium for grains ranged between 65 and 140%, and we need less than 10% to be profitable. So if we would just charge 10% more for food, that's nothing. A box of cornflakes in the United States, they tell me that it sells for $5 or $6 a box. There's 11 cents worth of corn in it. So just because we double the price of the corn doesn't mean the box of cereal doubles. Everybody wants their piece of the pie. We can pay more for food and get what we want, but you don't have to pay that much more, although as farmers, we like that much more. So where are those economics, where's that money being spent? Well, it's being spent on different things. In the organic system, you see we spend a lot more money on seed. We don't spend any money on herbicides, and we spend very little on fertilizer. In this experiment, we were putting on a little bit of potassium. So there was a little bit spent on fertilizer, but not much. We spend a little bit more on machinery, and we spent more on labor. But what is labor? Labor is your wallet. Labor is yours. When you spend it on fertilizer, you're giving it to somebody else. So we're trying to keep more of those dollars in our pocket. So I'm not an economist, as I already said. You're an economist. But I can tell if my income is higher, the green bar is the organic, the blue is conventional, and my expenses are lower, my net returns are going to be far greater. 3 times as much. I can understand that. That kind of farm economics I got. So we're making more money. Why are we making more money? Because consumers are valuing what we're doing as farmers. People say food is food, corn is corn. That's not true. That's like saying cars are cars. They're different. You pay more for a BMW or a Mercedes because, yes, it all has 4 tires and a steering wheel, but they're different. And our food product is different here. So when we look at the analysis again over time, our profits are between 2.9 and 3.8 times higher than the conventional systems. So farmers can actually make a living farming this way. So they're improving the health of the soil, they're improving the water quality, they're improving our health, and they're making more money doing it. No matter how we look at it, we can win. They're also using less energy. I showed this same slide to a group of people from the USDA, and they got really, really mad at me, really upset. And they said, well, look at this. This is the bar of diesel fuel used on the farm. Look, you're using more diesel fuel than the conventional system. Yes, but I said my energy overall is much less. And they said, yes, but you should leave the energy use to the professionals and not worry about it. This way you use less diesel fuel on your farm. What do I care? Here, this is something I can control. I can go buy a more diesel fuel efficient tractor. We're going to talk about organic no-till. I can make fewer passes over the field. I can control this. I can't control this. Here's that mineral fertilizer we talked about with Tropicana orange juice. Look at all the money, all the energy you spent trying to make that fertilizer. You didn't need it. Over here, look how little we used in the organic system. Yes, they said, but leave that to the professionals. Farmers don't know what they're doing. We're all idiots. This, again, just breaks it down to millijoules per hectare per year, so you can see where the different inputs are, and I don't even know what a millijoule per hectare is. I don't have to. I can compare the numbers across the board, and I can see that I used more diesel fuel on the organic system than we did on the conventional. And I used more in seed costs, but nothing in herbicide. Look at the fertilizer. It's huge amounts of difference in buying fertilizer. When we don't need fertilizer, we need microbes. Put the microbes in the soil, they'll give you the fertilizer for free. Again, not free, there's a carbon exchange, but dollar-wise it's free. So again, when you look at the energy analysis, we're using 45% more energy in the conventional systems than the organic systems. So another measuring stick. It's not just yield. It's looking at energy, because we know energy has a cost. We're also emitting fewer greenhouse gases. So we're not part of the problem anymore, we're part of the solution. You know, unfortunately, agriculture is not at the table at the COP21 meetings, or the Kyoto Agreement, or the Copenhagen Agreement. Agriculture is never at the table, and that's by design. Farmers, if you're not part of the problem, if you're not seen as being part of the problem, then you can never be seen as part of the solution. So we made it a point to make sure that Rodale was in France, in Paris, at the meeting, so we could be at the podium and talk about our research on carbon sequestration. And what they said after that meeting is, they said, next time we have a meeting, we have to invite agriculture to the table. It's a powerful tool that we just ignore. And it makes it easier for farmers, because if you're not part of the problem, then you can just keep doing what you're doing because you're not part of the problem. When in fact, we're a very large part of the problem. Just another chart showing you the same thing in numbers. So again, if you compare things overall, you look at yields, profit, energy, greenhouse gas, no matter which measuring stick you measure, we look better. The only one where we're lower is energy input. We use less energy. Everything else we maximize. So there's some key findings. First of all, it started in 1981, so it's the America's largest running side-by-side comparison. I don't think there's any in the world that compare the same kinds of systems we do as long as this has been there. We look at economic, environmental, and energy conservation impacts. We can improve our soil and offset greenhouse emissions, and yields and net returns are comparable and sometimes better between organic and conventional. The only reason I put this up here is we're looking for partners all the time to work on this. So if you have a piece of work that you're doing that you think would be relevant to what we're doing, we invite people from all over the world to superimpose their experiments on top of our laboratory so that you can gather the data that you need to help tell your story. Again, talking about our brown revolution, we really need to protect the soil. We need to build more resiliency into our systems. There's very little resiliency in our systems, and we need to do that if we want them to be regenerative. Of course, we have to make money. We all know that. FST needs to be dynamic in order to remain relevant. So again, inviting you to the table to help us look at changes in the experiment. You may have some ideas that you think would be very relevant there. It is a fixed experiment, but within that fixed rotations, we try to be dynamic because we don't want this experiment to be a dinosaur. There are agricultural plots out there that are dinosaurs, and they just kind of keep going, and they've outlived their usefulness. We don't want this experiment to be that. So the conventional treatments now use GMOs because that's what we're supposed to do. And we've seen the yields go down. But I've got a brother-in-law who is a breeder and an agronomist for a very large seed company, and I've been telling him for years that GMOs are worthless. We don't need them. And he just told me at Christmas, he said, well, we do side-by-side comparisons, and we know that our non-GMOs out-yield our GMOs. I said, I've been telling you that for years. He said, yeah, we don't like to admit it because we make a lot more money selling GMO seed. It's all about money. It's not about feeding people. It's not about improving health of soil. It's not about improving health of people. It's about different segments of the industry making money. And so our trial has to be relevant, and we do make changes and adjustments in the system. And right now, in 2015, we started looking at these things and trying to figure out, with our new research team, how we're going to maximize and exploit the characteristics of each system. So we're going to look more closely at soil microbiology. The exploitation means that in the legume system, we're going to get more legumes into the system. We're going to try to tighten that system up. In the conventional system, we're going to have less diversity, if possible. So we're going to say, but the industry's going this direction, we're going to follow that lead. And there may be more corn there. Even though we know it destroys the soil, that's not the point. That's what farmers are doing. And in the livestock system, we're trying to figure out a way that we might even be able to graze some of the plots so we can have hoof action and the different things that happen to the soil microbiology when the animal is physically on the land. And we're going to start to address the nutrient density of these crops. We just got a grant to fund looking at nutrient density, both vitamins and minerals, across these different crops that are actually grown differently. And we know that from anecdotal stories, there's good information out there. We have a neighbor who farms conventional corn and beans. And before we had GMOs in our experiment, we were trying to get some GMOs because we were doing a feeding study with the University of Wisconsin on rats. And he said, why do you want GMO corn and soybeans? I said, well, we're doing this feeding study. Oh, he said, I can save you all the money and tell you right now that your corn is better than mine. I said, why do you say that? He said, because my corn isn't as good as my grandfather's. He said, my grandfather kept very meticulous records of how he fed his livestock and what their daily rate of gain was, and I have to feed 20% more grain to get the same daily rate of gain he got 50 or 60 years ago. So the corn isn't as good. But he said, I don't get rewarded for nutritional value. I get rewarded for tons of yellow stuff or tons of brown stuff. That's what I get paid for. So that's what I produce. So we want to start looking at that and seeing what the differences would be. We do have field days at our farm. And so I would invite you to all come. If you all come at once, that'd be exciting, but you're always welcome to come and visit us at our field day events or anytime. We try to be as hospitable as we can, even when you show up at our doorstep.